Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. I also want to welcome the students of 12th Science, especially till chapter 8 Organic Chemistry and Alcohol. Now here in this video I want to explain the chemical properties, especially chemical reaction. What are the chemical reaction involved in the chemical properties of alcohol? Now this is part 7 where I will explain chemical properties of alcohol with proper equation. Types of alcohol, you know what are the types of alcohol? Primary alcohol, secondary alcohol and tertiary alcohol. What is the primary alcohol? RCH2OH. RCH2OH. In this carbon, one side alkyl group and there are two hydrogen atoms which are free to the carbon. Now in secondary, there are two alkyl group attached to the carbon and one hydrogen atom which is free. Whereas tertiary, you observe here, three alkyl groups are there attached to carbon, there is no free hydrogen and only one OH group, hydroxyl group is present here. Now then how they are active? In our primary alcohol, one alkyl group, what is alkyl group? Alkyl group is electron releasing plus I effect. So here electron released towards this carbon and here two alkyl group are releasing electrons towards their carbon. Here three alkyl groups release electrons towards this carbon. That means here plus I effect is very much compared to secondary than to primary. Now when we see the structure of alcohol except alkyl group, what is remaining? COH. C, that is electropositive, and compared to oxygen, oxygen is more electronegative. That is why it occupies delta negative charge and whereas carbon occupies delta positive charge. Now in this case, how can you say whether primary is very active or secondary or tertiary? Then what is the cause behind it? Tertiary alcohol, the CO bond is very weak. Then how can you know CO bond is very weak? Because here three alkyl groups are attached and they are releasing electron towards this carbon. That means plus I effect is more here. That is why CO bond is very weak. It can easily break. So CO bond is very weak due to plus I effect about the three alkyl groups. Where three alkyl groups, they will release electron towards the carbon. That is why this bond is very weak. Primary alcohol, what happened? Primary alcohol OH bond is very weak. Then how? Because here only responsible this oxygen, this hydrogen. Oxygen is more electronegative. Oxygen is more electronegative. That is why hydrogen tends to separate from this bond, to separate as a proton. That means hydrogen when dispatched, hydrogen will change, separate from this OH group as your proton. So now you can say then who is very active, whether primary or tertiary. Then when condition, when whether primary active or tertiary active. Now see, primary alcohol is active as cleavage of OH bond. I told just now OH bond is weak because oxygen is more electronegative. That is why here primary alcohol is active when the cleavage of OH bond. Tertiary alcohol is active when cleavage of CO bond. CO bond related mean, that means tertiary alcohol is very active. Then what is the conclusion? If OH bond cleavage, if we say OH bond will cleavage, then what happen? Primary is greater active more than secondary, more than tertiary. If CO bond will cleavage, then which one active? Tertiary is more active than secondary than primary. That means if OH that will break, then here the reactions are different because here primary is more active than secondary than tertiary. Similarly, when CO bond will cleavage, tertiary is more active That is why here also the reactions are different. Now we will say reaction due to cleavage of OH group. Just now I told OH group cleavage means primary is more active. Where I told OH is weak due to electron negativity of oxygen. Now what is the main reaction? First reaction you see acidity of alcohol. How can you say yes here acidity of alcohol proof? That means with metals, alcohol when react with metal, it gives hydrogen. This is the main characteristics of acid. When acid react with metal, it gives hydrogen. Similarly, alcohol also react with metal, it gives sodium alkoxide. When in ROH, H is replaced by Na, that is called sodium alkoxide and hydrogen. Similarly, we will see other metals how they react with alcohol. Here with metals it proves that hydrogen gas is liberated. Similarly, we will see other metals how they will react with alcohol. I told when metal react with alcohol it gives metal alkoxide and hydrogen. Here this is the example methyl alcohol with sodium. It gives sodium methoxide. Why this sodium methoxide? Because it comes from methyl alcohol. Sodium methoxide and hydrogen. Similarly, when aluminium will react, aluminium is trivalent. It will react with tertiary butyl alcohol. It gives tertiary butoxide. Aluminium, tertiary butoxide and hydrogen. And since aluminium has valency 3, that is why here it is 3 and it is aluminium. What is the formula? This is the tertiary buto and 3 times and here aluminium because aluminium has valency 3. Now acidity of alcohol. How can you know acid alcohol and what are the tests and also how can you compare different types of alcohol regarding acidity? Methyl alcohol where only hydrogen, 3 hydrogen atoms are attached to carbon and there is no alkyl group, you know alkyl group is electron releasing group where plus I effect is more, and primary alcohol only one alkyl group, secondary where 2 alkyl group and tertiary where 3 alkyl groups are there. And now it is one alkyl group, so once time one alkyl group tendency it release electron towards this carbon, and here 2 alkyl group they will release electron towards this carbon, and here 3 electron releasing alkyl group towards carbon. And plus I effect increases one by one. That means electron density on oxygen increases, and that is why polarity of OH increases. Polarity of OH decreases. If polarity of OH decreases, that means the H. What is acidity? That H will be removed easily and will not combine again to produce that again alcohol. If the hydrogen that has a proton removed easily and that is a stable one, then only you can say that is very good acidic. And so a plus I effect increases electron density. That is why you can say tertiary alcohol is less acidic than secondary, then primary, then methyl alcohol, because in methyl alcohol only hydrogen groups are there. There is no alkyl group. And how can you compare alcohol and proton? Alcohol that is also proton donor and water also proton donor. Now this is alkoxide ion where 3 pair oxygen are there with negative sign, and water there are 2 pair of electron, and now this proton donor, which one proton donor? Acid. That means the which one? Water. Water acts as a proton donor, so it is a strong acid. Now when you compare alkoxide ion and water, water is a strong acid. It forms conjugate acid and conjugate base. Conjugate acid and conjugate acid of what? This alkoxide ion. Conjugate base of what? This water. Similarly, it acts as a proton acceptor, it acts as a proton donor. Similarly, when you take only base where is a lone pair of electron having negative sign, and this is acid, that one alcohol which acts as a now acid let, then forms conjugate acid BH and conjugate base, that is OR minus. That means when you compare these two, you can say, you can observe water is a stronger acid than ROH. Water is a stronger acid than ROH. From this reaction, it is clear. Then we will see other chemical reaction of alcohol. In first reaction of alcohols, I told acidity of alcohol, how the alcohols react with metals and forms hydrogen gas, and sodium alkoxide is the main product. Now in second reaction, that is esterification. Esterification means ester will be formed by the combination of alcohol with acid or acid chloride or acid anhydride, with acid chloride or acid anhydride, and now they give the result that is called ester. Ester general formula RCOOR dash. What is the formula of ester? RCOOR dash. What is RCO? This part, this left side part, that is from acid. How can you name it? How can you know which part from acid, which part from alcohol? Because you know ester is formed by the combination of acid part and alcohol part. That means left part is acid part, right part is from alcohol part. But when you name, this part come first. When you name this part, which part? Alcohol part comes first and this part come next. That means suppose I can explain one example. CH3COO-C2H5. It indicates that this is from acid part, this is from alcohol part. This is from acid part mean this is from acetic acid by common name. This is from ethanoic acid by IPAC name. And this part from alcohol, see this part from alcohol, which alcohol? C2H5 mean C2H5OH, ethyl alcohol by common name. What is IPAC name of ethyl alcohol? Ethanol. So how can you name it? I told you name it from the right side. When you write from left side, that is from acid. When you name that is from right side, that is from alcohol part. So first you name, this is called ethyl and this is from acetic acid. So by common name ethyl acetate. Why it is acetate? Because it comes from acetic acid. Or by IPAC name ethanoate. Why ethanoate? Because it comes from ethanoic acid by IPAC name. So what is the name? Ethyl ethanoate. So I hope it is clear. It is now you feel very easy. Generally students feel face difficulty naming the ester, but remember left side that is from acid part, right side that is from alcohol part. When you name that means from right side you will name, you start then giving name, and next is this acid part. So it is ethyl acetate by common name, ethyl ethanoate by IPAC name. Then again come to our reaction of alcohol with acid. This is general formula of acid RCOOH, and this is R-OH, alcohol. This is acid, and what is the result? RCOOR dash. That means RCO acid part, OR dash that is alcohol part. Similarly, RCOCl, that is called acid chloride. RCOCl acid chloride, that means it is a derivative of acid. When you remove OH, here you RCl replaced by Cl, then RCOCl, that is called acid chloride, and this is alcohol. Same, the left part, that is acid part, and right part, that is alcohol part. Next come to example. Let us see, this is acetic acid by common name CS3COOS, that is acetic acid by common name. C2H5O is ethyl alcohol by IPC name. So what happened when they combine? Now I have shown here how the water molecule is produced as a byproduct, and what is remaining? CS3COOC2H5, CS3COOC2H5. Only you see and put the same part here, that means ethyl, that is called ethyl ethanoate. And what is the byproduct here? Water. Clear? That means in acid you put alcohol put in this way, so that it is easy to show how water is produced as byproduct. Then what is remaining? CS3COOC2H5. It is very easy now. Next come to ethanoyl chloride. What is meant by ethanoyl chloride? This is a derivative of acid. This is a derivative of acid. How? Because in acetic acid, OH replaced by Cl, so it is called ethanoyl chloride, or it is called acetyl chloride. Why it is acetyl chloride? Because from acetic acid. Why it is ethanoyl chloride? Because as a IPC name, that is called ethanoic acid, that is why ethanoyl chloride as IPC name, acetyl chloride as common name. When react with alcohol, example ethyl alcohol, then what happen? Again you see this Cl, this H, you write in this way so that you can show what is the byproduct. Sometimes byproduct is very important to remember all the reaction, how it is happening. Now HCl is the byproduct, then what is remaining? You copy and paste it. CS3CO O C2H5, CS3COO C2H5. It is very easy. That means you should know what should be the byproduct here, HCl, and what is remaining here, you copy and paste it here. Automatically the result or product will come 100% correct. Now CS3COO C2H5. This is the ethyl ethanoate. I already told ethyl ethanoate. Now this is called acetic anhydride. This is called acetic anhydride. Why it is called acetic anhydride? Because this is the combination of two molecules of acid and one molecule of water removed, and what is remaining, that is called anhydride of acid. So CS3CO, it indicates that it is from acetic acid. Two molecules of acetic acid, it gives on heating it gives one molecules of water, and what is remaining, that is called acetic anhydride. Now in this acetic anhydride, it is easy to mention in this way because CS3CO, that is two molecules of acetic acid, and here one water molecule removed, so it is combined with one oxygen bond here, and now this is called acetic anhydride by common name. Then what is IPAC name? In IPAC name, acetic acid is called ethanoic acid. So it is ethanoic anhydride. You can write, you can remember as IPAC name, that is ethanoic anhydride. In all other that is carrying in presence of acid. So CS3, see here, CS3CO, or you take CS3CO. What is the next part? This is OC2H5. So CS3COO C2H5. What is remaining? CS3COOH. CS3COH. That means here one side acid, acetic acid, other side ethyl ethanoate. Again you see CS3COO C2H5, or you can say CS3COO C2H5, CS3COOH. It is very easy. Only remember how it form ester and how it will form acid. Or in general you can say this is the RCO whole 2. See here 2 times. So RCO whole 2O. This is the general formula for acid and hydride, and you combine with alcohol, then you produce one side ester, another side acid. Here first I put one example, after that I put here general formula. In general formula you can see RCOR dash ester and RCOOH acid. I hope esterification process is clear, and now I will go to other chemical reaction of alcohols. Now we will see due to cleavage of carbon oxygen bond in alcohol. This is the second part of the chemical reaction where we will involve the carbon oxygen bond. How the carbon oxygen bond will break. Now you can see here tertiary alcohol, secondary alcohol and primary alcohol where the alkyl groups are more. Here tertiary alcohol, 3 alkyl groups are attached to the carbon, there is no free hydrogen atom, and secondary alcohol there are 2 alkyl groups attached to the carbon, only 1 hydrogen attached. In primary alcohol here only 1 alkyl group is attached and there are 2 hydrogen atoms, they are attached freely. Here you can see this structure, you can see here 3 alkyl groups attached, and what is meant by this sign arrow mark, that means they have releasing capacity, electron releasing capacity, that is called plus I effect. Electron donating nature plus I, electron withdrawing nature minus I. Now due to plus I effect the electron moves towards carbon. Now see alkyl group is electron releasing and it increases electron density on oxygen. Then what happens if the electron move towards oxygen, and here it polarity of this bond that increases and automatically it will break. Now if more alkyl group, more electron releasing towards carbon, and this carbon oxygen bond will break easily. That is why tertiary is more active than secondary then primary. You can see in primary 1 alkyl group, only 1 R, that is towards carbon, and 2 alkyl group towards carbon, and here 3 alkyl groups towards carbon. That is why the cleavage of carbon oxygen bond easier in tertiary, then secondary, then primary. Now means in the reaction which are involved due to CO bond cleavage, that means here tertiary alcohol is more reactive than secondary then primary. First reaction you can see reaction with hydrogen halide. Reaction with hydrogen halide, you should remember this is only due to breakage or cleavage of CO bond, because only CO bond will break, then OH will attach to hydrogen of acid, then only the reaction will be completed. That means here ROHHX, before that H part only undergoes reaction, but here due to CO cleavage, here what happens, CO bond cleavage, what happens, this OH totally will be attached or totally removed towards to hydrogen halide. This is the first reaction. Here I want to explain, that means OHH, again see from this RO alcohol H part, this acid H part, then what is the byproduct, water, then what is remaining, RX. So RX is the main. What is RX? Alkyl halide. What is the IP's name? Haloalkane. So important fact is here, that means here hydrogen halide when react with ROH, then the OH part of alcohol react with the hydrogen of acid gives RX and water. Then what happens, order of react, because you know halogen acids are so many types. You may use chlorine, you may use bromine, iodine. Now order of reactivity, HI is more reactive than HBr, then HCl. Then question is why? Because iodine size is larger than bromine, then chlorine. That means here if the size of in HI, if the size of iodide ion is more, then here the cleavage of HI bond become easy, and size of Br, the size of Br is less than I, but greater than Cl. So the order of reactivity HI is more than HBr, more than HCl. HI, the reaction is very easy with HBr, after that it is less reactive, then here HCl is the least reactive towards ROH, towards alcohol. But when come to alcohol, then what happened to alcohol? Because you know alcohols are three types: primary, secondary, tertiary. In primary 1R, secondary 2R, and that is tertiary 3R. R mean alkyl group. Alkyl group mean electron releasing capacity, and that is more. And here that is plus IF, inductive effect, plus inductive effect, plus I mean plus inductive effect. Then what happened? Tertiary is more reactive. Tertiary alcohol when react with HX, immediately product will form. Secondary alcohol time required, and primary alcohol, here you should write primary alcohol is least reactive. Actually what happened in this reaction, to make more reactive, catalyst is used. What is the catalyst? That acts, that is a Lewis acid, catalyst, that is Lewis acid. And what is that one? Anhydrous zinc chloride. Anhydrous zinc chloride is used as a Lewis acid that acts as catalyst. Actually this is called Lucas reagent. Lucas, one scientist name Lucas, involved in this reaction. He proved so many things in this reaction. That is why it is called Lucas test. Lucas test is very important to distinguish between primary, secondary and tertiary alcohol. Why? Because with Lucas reagent, that means with anhydrous zinc chloride, what happened here? Halides are formed. Halides are formed and water is the byproduct. These halides are what happened? It treated with water and it is observed. It is immiscible. Immiscible means some turbidity produce. But primary alcohol, secondary alcohol and tertiary alcohols are not producing turbidity in the same time, in the same temperature, because you know tertiary alcohol is more reactive, immediately turbidity will form, and secondary and primary they require some temperature. Lucas test, again I will explain properly how it is helpful to distinguish primary, secondary and tertiary alcohol. I told Lucas test. In Lucas test, Lewis acid, that is anhydrous zinc chloride, is taken, that acts as a catalyst. Now this Lucas test is very important, how to distinguish between primary, secondary and tertiary alcohol. Generally when react with hydrochloric acid and in presence of anhydrous zinc chloride, corresponding haloalkane is produced. Haloalkane generally immiscible with water and produces turbidity, but depends on the type of alcohol, whether primary, secondary and tertiary, the turbidity appears according to the time and temperature. Now we know tertiary alcohol is very active because here three alkyl group, electron releasing group are present. And now here you can see this is the tertiary alcohol react with hydrochloric acid. In presence of anhydrous zinc chloride, it produces haloalkane. What is that haloalkane? That means here having three alkyl groups. So here turbidity appears immediately because we know tertiary alcohol is very reactive. Next come to secondary alcohol. Secondary alcohol also gives haloalkane, but here the turbidity appears after 5 minutes because it is less reactive. It is mean secondary alcohol is less reactive than tertiary alcohol. And next, primary alcohol. Primary alcohol, when treated with hydrochloric acid and hydrogen chloride, it produces corresponding halide, haloalkane. Here the turbidity appears on heating. Why? Because it is least reactive, or it is less reactive than secondary. Secondary is less reactive than primary. That means here easily one can distinguish between primary, secondary and tertiary alcohol. If after treating with HCl and N-hydrogen chloride, if alcohol gives turbidity, immediately tertiary. After 5 minutes it gives turbidity, then secondary. Or if you say turbidity appears on heating, then you can say this is primary. So one can distinguish easily between primary, secondary and tertiary by the treating with hydrochloric acid and N-hydrogen chloride, that is called Lucas test. Then come to with phosphorus halides. So many phosphorus halides are there. Important are phosphorus pentachloride, phosphorus trichloride, phosphorus tribromide. But phosphorus tribromide is not existing. So phosphorus plus bromine, you take phosphorus plus bromine, it gives phosphorus tribromide. Similarly, phosphorus triiodide, here also you will take phosphorus and iodine. Now you see, if you take alcohol and PCl5, it gives corresponding halide, and oxygen comes to phosphorus Cl or phosphorus chlorine and exists as a compound that is called phosphorus oxychloride. That means this oxygen comes to here and this here chlorine attached to here, that is called ethyl chloride, or you can say chloro, that one ethane, 2 carbon ethane, chloroethane. Similarly, if you take PCl3, now see here 5 chlorine atom, here 3 chlorine atoms, so the byproduct different. What is their byproduct? Here you will get S3PO3. What is S3PO3? Phosphorus acid. Similarly, if you take PBr3, PBr3 is not available immediately, so you will take phosphorus and bromine. Then after that immediately it gives PBr3, and here CH3CH2Br. That means bromoethane plus S3PO3. What is that? Phosphorus acid. Then CH3OH PI3, similarly P plus iodine you will take, and here it gives CH3I, mean iodomethane, S3PO3 phosphorus acid. Again see, with PCl5, the byproduct you should remember POCl3. What is POCl3? Phosphorus oxychloride. Similarly, and hydrochloric acid also available, and here PCl3 it gives chloromethane and S3PO3. What is S3PO3? Phosphorus acid. Similarly, in 3 case PBr3, PI3, the byproduct is S3PO3, and corresponding haloalkane is produced. For bromine, bromoalkane, for iodine, iodoalkanes are produced. Similarly, point 3, with thionyl chloride. See, this is one type of chloride of phosphorus only, and here one type of chloride that related to sulfur, and that is called thionyl, SOCl2, thionyl chloride. But here pyridine used to take. Then what happened? Here also haloalkane produced, and now what is the byproduct? What are the byproducts? Always try to remember byproducts. If you remember byproduct, then immediately product will be correct one, because you should know what are the byproducts and what is remaining, what is maybe the product. So here the byproducts are SO2 and HCl. Remember, SO2 is a gas, HCl is a gas, both are gas. So both can be removed easily, no problem, without any problem. Both can be removed easily. What is then remaining? Remaining only RCl, haloalkane, that is a pure form. That pure alkyl halide, how can we get? If you treat thionyl chloride in presence of pyridine, it gives haloalkane, and the byproduct, the SO2 and HCl both are gas. So they can be removed easily then so they can be removed or separated easily, and so here this method is very important to get a pure haloalkane. Next we will see other reactions involved in the chemical properties. I have explained so many reactions. Now we will see what are the conclusions that of the all the reactions of alcohol. What I taught in this video. Reactions of alcohols are different types here. One is due to cleavage of OH group. That means here between O and H the cleavage takes place, breaking takes place. Then here what are the possible reaction? Acidity of alcohol. Alcohol is acidic nature, already explained. Esterification, that means alcohol will react to the acid anhydride, acid chloride, that it will give ester. That is why the reaction is called esterification. Then come to second one. This one also I taught. Due to cleavage of CO, between CO, the cleavage takes place, breaking takes place. That means what are the possible reaction? And here also you should know tertiary alcohol is more reactive than secondary alcohol, than primary alcohol. The already I told the cause, and the following reaction here what I taught in this video, hydrogen halide. Hydrogen halide means here if alcohol react with hydrogen halide, it gives corresponding halide. Suppose it did to the HCl, it will give alkyl chloride. Similarly, here one important test that is called Lucas test, and HCl plus N-hydrogen chloride, here it gives the corresponding halide. Primary also gives primary halide, secondary gives secondary halide, tertiary also gives tertiary halide. But what is the main important point here? Now all are giving halide that are turbidity in nature, but only differs is time. Primary alcohol gives turbidity only after on heating. Then secondary alcohol, it gives turbidity after 5 minutes, and tertiary alcohol it gives immediately. It gives turbidity immediately. That is why it is very easy to distinguish between primary, secondary and tertiary by the help of Lucas test. And so it is very important and practical also. Next come to with phosphorus halide. Phosphorus halide, that will phosphorus halide PCl5, PCl3, Pi3 like this, they are called phosphorus halide. When alcohol react to this phosphorus halide, they give corresponding halide, and that is also very important. Next one, with ethynyl chloride, that is not completed in this video. With ethynyl chloride, it gives corresponding halide, but important is that SO2, sulfur dioxide, and HCl both are given as byproduct which easily escape. That means you can get here pure alkyl halide. In coming video, I will explain the reaction of thionyl chloride with alcohol in proper way, and next with other also reaction I can explain other reaction. And here only with phosphorus halide I have completed. Hope you will subscribe my channel BL Das Hot and Sweet in Chemistry. In coming video I will explain the reaction of thionyl chloride, reaction with thionyl chloride and other reactions of alcohol.